Hello, everybody. I'm Olga Russakovsky. I'm an assistant professor in computer science at Princeton, and I'm very excited to be part of Athena. So I run the Princeton Visual AI Lab, and let me tell you today a little bit about what we do in the lab, and in particular about three sort of big research themes that we're working on. So the first one is the theme of perception. So we are trying to build computer vision systems. We're ultimately a computer vision lab to understand, and these systems are trying to understand what is happening in the scene, right? So this is things like working on tasks like object detection or scene understanding, action recognition, or perhaps vision and language, actually being able to connect the visual input to some kind of natural language description. And one particular theme here that we've been looking a lot at is the question of video understanding. And we have a number of prior work sort of moving beyond just still images to try to understand real world data, which is frequently in the context of videos. So much sort of richer, larger scale data than just still images. We have a number of prior work, and I should say this is both the work in my lab as well as some of the PhD work by a postdoc who recently joined the lab and who will be part of Athena. So some of the challenges when we're working with video, particularly working with activity understanding in video, right? So we need to focus on fine-grained distinctions between activities because sometimes those very small visual differences actually contribute to completely different inferences made about the action or the intention of that action. Activities are fluid, morphing between states, much more fluid than something like object detection, where objects are much more clearly defined, have much clearer boundaries. Any kind of video understanding work calls for contextual temporal reasoning. And then fundamentally, underlying all of this is the requirement for model efficiency. So in video understanding, typically what you're most limited by is just computational just the sheer computational complexity of this task. And so some of our plans at Athena are, of course, both to expand on the accuracy and robustness of these models and start thinking really about real world deployment of these video understanding systems that we're building, but really fundamentally focus on model efficiency to enable deployment and to actually start thinking about how we can have these models run across a network, run in a real world setting on real data at scale. And the plan is to leverage the interdisciplinary team to bring together new technical expertise to this domain and actually, again, enable practical impact. So this is our first theme, right? It's the theme of perception in the lab. Our second theme, which I'll mention very briefly because it's not as related to Athena, is the theme of interaction. And so here we're thinking about how to best leverage and collaborate with humans in the context of, again, building these AI models, particularly for visual recognition. And so a lot of the time in the previous work that I've described, that's primarily focuses on building better models, better across a number of dimensions. But really, we can also ask questions about how to best leverage human expertise, right? So there's optimal human supervision or human machine dialogue, or I'll bring in insights from human learning into these systems. Okay, but let me talk quickly now about the third theme, which is, again, very relevant to Athena, which is zooming out right beyond perception, interaction, zooming out even more to fairness. So questions of who is represented in these AI systems. And more over the past few years, as these systems are being deployed at scale, there's questions about fairness and bias. So there's headlines both in the sort of public eye as well as in the technical community asking questions like, okay, there's computer vision model that learns to quote unquote increase attractiveness by manipulating skin color. Machines taught by photos that learn a sexist view of women. Or facial recognition is accurate if you're a white guy. And there's very rich questions about why is this happening? How can we try to mitigate this? There's a lot of excellent literature written on both the root causes as well as the societal impact of these kinds of effects. For the purposes of my lab and the work that we do, we try to simplify this into just thinking about this cycle, right? So there's some kind of human history, bias, and prejudice that's making its way into large-scale data, which is being learned by the AI models, becomes part of the AI decision-making, and then becomes part of our human history. And so our goal is to try to offer constructive computer vision and machine learning solutions to try to mitigate the effects of this cycle. And so again, we have a number of prior works, both looking at data set analysis and metrics and measurements within data and models and systems, doing modeling, understanding, and interventions from the perspective of bias mitigation. Also our work on diversity and inclusion, which is very relevant to asking about sort of the root causes of why are there biases in the systems. And there's a number of challenges like translating these complex societal forces into quantifiable metrics and as well as rethinking the entire pipeline of data collection, measurement, and modeling, and interaction and inclusion. And really fundamentally, this requires interdisciplinary analysis and integration. So this is not purely technical work or purely social work, it's really at the intersection. And so some of our plans at Athena are to expand this work beyond just the computer vision setting to machine learning and more broadly, to apply the fairness, interpretability, and ethics lens to work done across the center in a number of other sort of technical domains. And really, again, to leverage the interdisciplinary collaborations to deepen our understanding of fairness and bias and policy and ethics in technical systems more generally. So what kind of questions should we be asking, and what are the kinds of mitigation strategies that have worked? So these are some of our key themes. Very excited for the kickoff, excited to be learning from this group. Thanks very much.